Hello, welcome to the second Kafka Meetup hosted at Confluent. My name is Guozhang Wang, and I'm a PMC member of Apache Kafka and an engineer at Confluent. And as many of you know, this is actually the second event of the Bay Area Kafka Meetup hosted at Confluent HQ. We want to use this opportunity not only to talk about the newest development and the features that is happening at Apache Kafka, but also what challenges that people at Confluent and other companies are facing and tackling on a daily basis, building the streaming platform and the ecosystems around Kafka. But most importantly, we want to use this venue to simply to know each other. And we can talk about what exciting projects and new ideas that we are considering and we are working on in this real world area. And all the presentations, just like the last time, will be video recorded, and the slides and the recordings will be uploaded after the events. And after all the three presentations, we'll also have an additional QA and networking sessions as well. Let's welcome Rajesh.
Thanks, Guozhang. Yeah, so today I'm going to talk about how we can deploy Confluent Platform in Kubernetes through Confluent Operator. So my name is Rajesh, and I am software engineering at Confluent, working on the control plane team. So basically, we're going to deep dive about Confluent Operator features, how Confluent Operator provides external access, how seamless security configurations is configured through Confluent Operator, lifecycle management, generally focus on like how we install, update, and then scale up, scale down the whole Confluent platform. That means like we can Kafka, schema registries, KSQL, all that stuff. And then we're gonna like a deep dive on demo. So we're gonna focus on deploying all the Confluent platform on GKE cluster. And then we can have a Q&A session. So before going to the Confluent Operator, we have to figure out or understand why Kubernetes. So Kubernetes provides platform to automate all the container applications. That means whole lifecycle management. So it can deploy, scale, and manage of container application. What it means is that in general, Kubernetes gives infrastructure abstraction extension, right? That means it supports varieties of volumes, storage, and networking. That's one of the benefit of Kubernetes, so that we can run one application on one. You can write application on one infrastructure, and that same application can be run on multiple infrastructure on top of Kubernetes. That's one of the benefit. The other benefit is the extensibility. Means Kubernetes comes with its own core Kubernetes APIs. So, but there are like complex applications like Kafka, where it requires a lot of the composition of Kubernetes objects to even deploy on the Kubernetes. So that also gives like a easy extensibility. So that helps to drive whole like, this operator ecosystem on the Kubernetes. And then Kubernetes, most of you guys probably know Kubernetes runs on the controller model. So that means every construct on Kubernetes resources has corresponding controllers. So for like replica set, you have a replica control. The idea about controllers is to make sure to drive current state to the desired state. If you say like to the Kubernetes, hey, create me three parts for replica set, then Kubernetes ecosystem makes sure that the desired state will have a 3 parts running. So that is like independent driven. So and then controls itself runs control loop, right, which has all these 3 states called observe and finds the diff and then acts accordingly. So that's why like, Kubernetes is like kind of de facto for the application running on containers. So now let's going back to like challenges, right? So now we know like we're gonna run Kubernetes and we're gonna deploy a Confluent platform on Kubernetes. What are the challenges on the Kubernetes? So the big one is like when you want to deploy complex applications like Kafka, you have to composite a lot of Kubernetes abstraction or like Kubernetes core like resources, pods, nodes, stateful set, services, config maps. and secret. There are ways to do through Helm chart, right? You can configure all this stuff and deploy this stuff, but you don't get operational aspect around doing through Helm charts. So one of the ways like operator helps us to model some kind of abstraction, and then controller, which are custom controllers, can run those abstraction to create respective Kubernetes resources and then watch on those. And the other challenge is actual access to Kafka, especially for Kafka, because clients has to know or talk to each brokers. That means clients can be outside the Kubernetes. That means it requires actual access. That means it has to set up load balancers. And then Kubernetes comes with the abstraction of load balancers through services, right? So, but with enterprise listeners, you also have to worry about security. There are like a security configuration we have to worry about. And there are different kind of security configuration we have to even, Kafka supports on that. So we also need to figure out that stuff. The other big one is configurations, right? Configuration are one of the most challenges faces on all these platforms, because there are so many configurations, and then configuring itself is kind of hard problem to solve. So Confluent operator try to solve giving like a default configurations and then also provide some kind of override capabilities, so that most of the customer will go with the default configuration, everything sorts out with the right security. If something has to be changed, like I want to disable auto topic creation, then you can go and change those kind of stuff. So any configuration can be overridden. So those kind of capabilities we also have to provide through operator model. And the storage is the big factor, right? Every components uses storage, and every infrastructure has a different implementation of storage. We want to have some kind of abstraction like storage class, so that operator works from the storage class perspective, so that operator can create like a PBC claims on those storage, and it doesn't even care what kind of storage volume it uses behind the back. And then same thing with the upgrades, right? Every time upgrading Kafka is so complicated. So you really want to make sure that when an operator scales up and scales down with like Kubernetes command, it should just take care of all the manual stuff operating. So those are like one of the challenges. Sorry, my bad. So like before deep diving in operator ecosystem, let's talk about how Kubernetes provides these extension capabilities, which are like, there are two types. One is the aggregation layer. There's the aggregation, one is the CRD model, which is custom resources definition. So custom resources definition adds the capability to provide new name and schema on the Kubernetes. And then custom like resources are just the Kubernetes APIs, extensions on the existing Kubernetes like resources. We have like different kind of like resources. We have workloads like deployment, stateful set. We have container-centric abstraction parts, replica set, all this stuff. So the Kubernetes extension CRD model provides you a way to add new kind, or the abstraction which can be a Kafka kind. And the job of that CRD is to get all the information from the user, and then use custom controller, because there is so when you install custom resources, there's a corresponding controllers, because that's the only controller who can understands all the events based on your custom controller. So as an example here, on the right side, you see there's a Kafka based controller, the CRDs, which is like custom resources. And then every time it is like applied to the Kubernetes API, all the events are cast by the custom controllers, and custom controllers knows how to parse this information and create all the required Kubernetes like resources. So before that, then yeah, and now let's talk about Confluent operator. I just gave like a brief introduction, like how this custom controller works. So Confluent operator itself, if you see here, we have it's a two-part architecture. So on the left side, you see manager, which manages two controllers, Kafka and Zookeeper controller, which actually uses configuration library, which has all the default configurations for each component. And then that creates the PSC resources, which is a custom resources, and then applies to the Kubernetes. And on the right side, there is a PSC specific controller, which understands how to parse the PSC configurations and then creates all the required stateful set, config maps, service, secret object, all the PBCs. So PSC is kind of like a blob, but the only control, the PSC control knows like how to parse those stuff and then creates the right application. That can be Kafka, that can be Zookeeper, that can be any other Confluent platform components can case stuff. And then there are like basically multiple ways to call Kubernetes. One is like Helm charts, or you can use kubectl apply command. But we are using Helm charts to package all this stuff, so that will become easier because Helm charts comes its own like a packaging management system. It has all the release, all these cool capabilities. So Confluent Operator high level, we support like Kubernetes 1.9 plus because CRD is going to be on like after I think 1.9 you're going to beta. So and like it has a lot of capabilities we want like a status capabilities so that we can run scale command on the kubectl stuff. And helpzard is like a corresponding to Kubernetes version. So we support almost all Confluent platform components except I think REST proxy. We support like two kind of Docker registries, like Docker images. One is Red Hat best for enterprise customers, and then Debian are like okay. Okay, so for the so Red Hat are generally used for like OpenShift has a strict rules that it has to deploy Red Hat images. That's why we also support Red Hat based like Red Hat images for all CP components. So deployment. So since we are part of like Kubernetes abstraction, we support different varieties of like Kubernetes, right? In general, if you see Kubernetes, there are like three kinds of like managed Kubernetes you can get from public cloud. Distribution you can use like PKS, OpenShift, and any other versions of Kubernetes distribution. And roll your own like is like more like if you are using your own kubeadm commands or kops, your own way of deploying your Kubernetes. We support all these platforms. So features, right? Features. So these are only high-level features. We support pods. So Confluent Operator supports pod security context, which is very important because we don't want to run Docker as a root, right? Which has a lot of problems. And there is a way you can control what kind of UID you want to run for the process running inside containers. All the volumes are abstracted through storage classes so that operator only cares about like what storage class need to be used, and then it doesn't care about what is backed by that storage classes, right? That is something administration of like Kubernetes has to manage. So every component comes with readiness check. That means that for Kafka, we have our own like internal readiness check. For all the components, we have readiness check to make sure that when the pod starts, means that it is actually working as expected, those kind of stuff. Pod placement is very challenging problem. For public cloud, it's easier problem because they use storage class per available zones. Then you can place pod on the storage class. You can place pod on those particular zones through PBCs because PBCs has a map to storage classes. So we create storage classes per zone. So that way, when the pod goes to one zone, and that uses the same storage classes. That is for public cloud. For on-prem customers, like more, it's up to affinities, node affinities or pod anti-affinities based on those, and then it has a capability to configure the stuff. And then it can take any images, means that when you have a newer version of like components, you can just go and just change those, and it can just get those versions, and then it's gonna do rolling upgrade, so that customer don't have to worry about like what it has to be done to do a rolling upgrade stuff. Actional access, it also has every component supported actional access, but broker Kafka is a bit tricky because Kafka, we create a bootstrap endpoint and the load balancer map to each brokers so that when clients communicates, it communicates with the bootstrap endpoint so that it doesn't have to like directly connect to all the broker endpoints. As I said, every component comes with default configurations to make it easier, but there is a capability, we can always change that. Like we have like override capabilities. So that means that every time you feel like something has to be changed because the default configuration doesn't make sense, then it does the rolling upgrade, all that stuff. Yeah, so thanks, Michael. So Michael is our product manager for this team. So that's a Confluent operator. So lifecycle management is very straightforward in Kubernetes, right? Once you have a Kubernetes, Kubernetes supports lifecycle management, install, upgrade, and scale up, scale down. But there are like a situation where we have to write like pre-hooks. I mean, if you guys know what Kubernetes, to make sure like Kafka like gracefully shutdowns, like and then those kind of stuff. Monitoring and logging are like a first class like citizen. So that means every time you deploy components, it comes with a JMX and Jolokia metric like endpoints. So that means technically you can integrate with any third party like like tools. And then we use help desk to configure this stuff. External access is interesting. So for Zookeeper, we don't open external access. For all other component, we open external access. On the help chart, if you see on this example, it's so simple is that all we have to do is change the type. So type dictates if it is a service type load balancer, is the internal, is external load balancers, public facing load balancer, which is like external, and the other type supports internal, which is like a VPC paired. It's the internal load balancer. And then for the OpenShift, because OpenShift uses a different mechanism, they also support like external, but they use like route. Then you can just configure type route, and then everything's taken care by operator. So all the route objects, what need to be added, all the host information, everything will be taken care by the operator. For some other like because Kubernetes has extension capabilities, there are different like load balance integrations which require different annotations. So and then you can also pass like annotations which actually going to be injected on the service types, and then those stuff. So this is example for Kafka, because you can run multiple Kafka cluster on the same Kubernetes, but you want to make sure your brokers has a different endpoints, right? So that's why you can change both like bootstrap prefix and broker prefix. On our demo, we're gonna talk about like how this looks like, all this stuff. So yeah, so we talk about like OpenShift is very different. So because OpenShift uses TLS SNI magic to find the pod. So that means every route object or DNS is pointing to the route load balancer. So technically every like DNS records you have created gonna point to the OpenShift route load balancer. And then based on the TLS SNI, which is the extension of TLS, it figures out like which backend it has to go. It generally is a host name matching, like whatever the request client does, those kind of stuff. And to make it simplify, broker advertised listener changed from 9092 to 443, which something customer don't have to configure, like nobody has to configure. The operator takes care of changing the advertised listener, because the reason is when you call the bootstrap endpoint, you're gonna get back all the metadata, which will have all the endpoints of the is brokers that comes from the advertised listeners. And then that requires 443, because by default OpenShift route supports 80 and 443, but there are ways to change those stuff like to other ports, but that's the default configurations. Yeah, so let's talk about security, because this is the most complicated stuff. So So every component today, so we have like a multiple ways, like Kafka uses L4 type, like load balance, like sorry, Kafka has a different like a type, like authentication type is a SASL is there, TLS mutual away is there, and SASL has a different authentication type, right? Today we only support SASL plain and SASL like authentication type plain. For TLS we support like both server authentication and mutual authentication. All the component who have REST endpoint, we support mutual authentication as authentication type. The operator configures all the default ports. There's no way, so there is no option for users to change ports because that comes with the operator, because operator takes care of configuring the ports. And then the configuration looks pretty simple. All we have to do is just change the authentication type. So by default, if the TLS is disabled, let's say this is the configuration for Kafka. If the TLS is disabled, it's a SASL plane. For internal, so there are two kind of like clients, right? Sorry, one is internal, one is external. So we open 3 ports, 9071, 9072, and 9092. 9092 for external communication. For internal clients, which are running internal, they have a choice. They can point to 9092 or they can point to 9071. 9072 is for interbroker communications, but none of the information is open here. So all it has to do is you just change the type if the TLS is true, and then there's no authentication type. This is SASL SSL. If it is if the type is a plain, then it is a SASL SSL plain with enable. If it is a TLS, then it is just a TLS to like mutual auth. So and then there are 3 things we have to support, because each components try to communicate to Kafka. Those are clients. So if the Kafka is configured for TLS mutual auth, then that means that it has to trust the certificate. So on the trust, like anything we add on the CSRs, which are PEM format, are translated to the PKS12 format, and then injected on the like a container, and then those are used by the applications. Full chain and private. So private key is the server like server key, and the full chain is a full chain means like it's a full chain, right? You can have a intermediate certificate, you have a root CA, and you have a server certificate. You can just add that stuff there. Lifecycle management. So on the install part, it's pretty simple because we use Helm as a packaging system. You can run like Helm install or kubectl apply if you feel like Helm is not security compliance because it has its own concerns. Then you can generate all the templates, Helm template, and then run kubectl apply, and then that is taken care by the command. The prerequisite is because operator requires storage class names. So that is something created through Helm charts. So storage class are not part of the operator. It's like something Helm charts deploys the storage class, and then those storage classes are used by operator when it deploys the applications. And then since operator runs on the cluster, like cluster level access, like cluster role. So that means it actually watches all the namespace. That means you can run multiple cluster types. Like you can run Kafka cluster, you can Jupyter cluster, you can run KSQL cluster. You can run any cluster on any numbers. It just manages those because it has a cluster level access. And then configurations are something we're going to talk a bit more. So there are 2 kind of like configuration. If you think about configuration, one is a static configuration where we know beforehand these are the values, right? You like auto topic creation is a true or false. But there are some kind of like configurations which are runtime configuration where for Kafka you have to know like what's the name of broker ID, and then for there's a broker rack configuration, like you have to know like where you are, which pod is under which zone, those kind of stuff. And then there are server peer. Server peer is for like Zookeeper. So that means that there are something like an operator has to take care to create this configuration on the runtime. And then how this works is, if you see this diagram, so Confluent operator watches like resources, right? We have a Kafka resources, we have a PSC resources, and then operator creates all the required stateful set, PBCs, config maps. So on the config maps, we actually create 2 config maps. One is a shared config map that is shared across the cluster. One is a pod level config map. Like broker ID is a pod level config map because you want to know what is the ID of the broker. Because sometimes your cardinal value of stateful set might be different than the broker ID. And then what it does is, so once this two config maps were created, it injects, so we run init container. So, and then init container has a capability to read pod configuration, which is some kind of templating engine. So we run some templates. And then the init container runs that templates, which has a pod ID information because it all requires the ID and the cluster domain. Because Kubernetes by default uses spc.cluster.local, but a lot of customer want to change that to something, right? Because they want to manage their own certificates. You can do that stuff. And then the init container reads whatever is mounted on the mnt config pod, and then it parses that template and then writes on the mnt config, which is shared between init container and broker container. So, and then broker container reads that configurations and then uses that configurations when starting the applications. Yeah, rolling updates. I mean, a lot of features are already provided by Kubernetes because we piggyback stateful set, but there are like version updates. Like every time, like we come with a new version of our component, all we have to do is just update the Helm charts and just deploy. That will take care of all this stuff. Every configuration overrides are kind of shared like across the cluster. So that means we have to roll the whole cluster. So the stateful set already supports like one of the order type, like rolling order type. So it takes up those stuff. And certificate objects are very important, right? So because today we expect users to pass certificates. That means it's a user who has to manage the lifecycle of certificates. So, but for the Kubernetes, if somehow they have this some kind of like a capabilities to tell that, hey, the certificate is getting expired, then all you have to do is just update, run with the Helm update command. It's gonna just update the secret object and then roll the cluster. But in long term, we really wanna do dynamic certificate loading so that you don't need to roll the whole broker clusters. For the other components, you have to roll the whole clusters. And then Kafka, so one of the things is like every time you scale up or scale down, we want to make sure it ensures that under replicated partition and offset partitions are 0, so that it like gracefully shut down. So that means that there is a pre-hook execute, like something we run on the pre-hook that makes sure that things are like okay to gracefully shut down the brokers. Yeah, scale up, scale down is a pretty, so you can do from Helm update, you can, we can do from kubectl edit command. You can actually do from the kubectl scale command. If you have a like latest version of Kubernetes, CID already supports sub-resources, you can just run those commands. And then for scale up, so when you scale up, scale down, we don't restart existing running cluster. So that is, we just add new cluster. For scale up, especially for Kafka, right now, today, we still expect to run manual ADB. That's our IP. But long term, we are planning to automate this capability where when you scale up, like internally, the ADB get triggered, and then it makes sure that it replicated correctly. And scale down is, as I talked, like we already run pre-hook stuff. Yeah, so we're gonna do demo. Hopefully it's gonna work because we do like DNS. So we have to create a DNS record, and sometimes it takes time to resolve those DNS, but let's see how things goes. So we have like so before going to the demo, so these are like Helm charts configuration. If you see Helm chart, right, all we're asking is, hey, where you want to run, which region you want to run, if the deployment, your Kubernetes deployment is multi-zone or single zone, because we have to create storage classes for that, and then configure storage stuff, and then these are like registry configuration so that we, it pulls the, so that it pulls the images and SASL plain text. This is a way to, this is a configuration for interbroker, because the demo I am going to present is SASL, SSL best, but you can do like other TLS based also. Zookeeper, we're just running 3. Kafka, if you see here, load balancer, we are using this domain name. The prefix of the bootstrap endpoint is a Kafka demo dash, that domain name, and every broker will have a prefix C0 dot platform, C0 dot domain name, whatever domain name is, C1, C2, C3, based on how many Kafka you are running. We have metric reporter, and then on TLS, you have this is a plain type. That's why it's a SASL SSL, because TLS is enabled. This is a SASL SSL of type authentication type plain, and CS certificates. If you see, these are like just a demo self-signed certificates. It's just a root CA. It has a server certificate as a private key. Same thing with Connect. You have so everybody follows the same pattern. So like once we configure for one pattern, it's exactly the same kind of other pattern. But one thing interesting is, so for control center, it has a lot of dependencies. So there are like sections where we can just configure like dependencies. So on this dependency, we can say like, hey, I mean, this is not required. This is just like this is the initial configuration, because we need to know the topic replica, like internal topic partitions, sorry, replication factors. And then here, bootstrap endpoint, since it is internal, so it can use a service name of Kafka, which is the name Kafka, and then it can point to port 9071, which is the internal port. But it has, for all the external clients, don't have access on 9071, it has to go to 9092. And then same thing with Zookeeper, you can just configure. And then for TLS, because we need to know what kind of Kafka configuration is required so that control center can talk to, so we just have to configure those. And then this is the interesting thing is, suppose if you want to change to true, that means you are actually even running TLS encrypted from the control center to the Kafka, those kind of stuff. Let's go to the demo. So this is DK cluster. I think this should not be down here. This city namespace W. Yes, nothing is there. I have this script. We have this script where all we're saying is that, hey, this is the same GCP.yaml file I just showed you guys. So, and then it is a platform in GCP, and then C is like, hey, deploy all everything. Right? And then, yeah, all the components. So whatever like Confluent operator supports. So what it does is checks the checks like a Helm chart is installed, if it has access to the Kubernetes, like this stuff. So operator got created. Just let me do something there. So what it does is, so if you see on the first two, right, it creates the manager and operator, as we talked like for architecture. Then it's going to start like Zookeeper, and then once the Zookeeper are off, and then it's going to create Kafka, and then it creates all the components. So during this module, like initialization, there are templating engine, as I said, there are dynamic configuration it has to create on the runtime. So those will be injected to the main container, and then that can, and then the application uses that information to start, and then Kafka starts. Then sorry, I just have to use this here. If you so here, let's say let's do. So you can do like cube, and I just want to make sure I'm in the same context that I don't need to write. So here, so if you do kubectl get Kafka, so you have a Kafka resources. If I do OYAML, and then right now it's on the pending state because it's not started. So this is our custom resources, support security, all these options we have. But if you see here, there's no configurations. So because by default, I mean, the Helm chart configuration doesn't have any configuration override like configured. That's why there's no configuration overrides. And then you can, so the good thing here is you can see status. So that means that because to access Kafka, you need a client, right? Clients, if it's a SASL base, then you need like a configs, the configuration which will have a JAS files, right? JAS configuration so that you can communicate. So status is going to show all the required examples, like what is required to connect to the Kafka once this is up, right? So here now we are provisioning. So if you see here, this is a Zookeeper Connect. So this is the way it has to do. It has all the configuration, and this is the important pieces. I think it's too big. So any internal client which is running on the Kubernetes, they can use this kind of configurations to communicate to the Kafka when you create topic and produce and consume all that stuff. These are default passwords. And then for external client, so external clients could look different, right? External client actually created a DNS name called, this is the broker endpoint, which is our bootstrap endpoint, because it's not like pointing to its brokers. It's just a service load balancer back which selects all the running brokers. Yep. And yeah, so any client like inside, they can use both, right? It depends, like if they want to do fully TLS communication, then they have to use external client configurations. If they don't even, if we don't care about security, then we can use internal clients, which is, so these ports are different, right? So because this port is configured as a SASL claim text, this port is configured as a SASL SSL. Just give me a second here. This is the one, should be here. I think we're almost done. So if you see here, all components are created. So control center takes some time to start because it has all the dependencies. It has to check. So now let's say we want to produce and consume. First, let's verify if the load balance. So all the DNS are resolving or not. Let's say Kafka replica is 3 running on operator. Yeah, so yeah, it's still taking time. So for all the brokers, all the load balance are resolved. These are the DNS names for all those stuff. It's probably going to take some time for this stuff. Hey, you guys have any question? Let me know, because hopefully it will be resolved. Correct. Yes. Sorry. You mean the? Oh, so yeah. So if you see here, yeah, no. So
so my question about the metrics, Kafka metrics. Where is these metrics? Who does provide them? So just a general.
I mean, if I understand your question correctly, right? So when we deploy Kafka, if you see here, service Kafka, I can see that. Sorry, my bad. So if you see here, so we enable JMX and Jolokia metrics endpoint. So it's up to actionable like components to go and grab those metrics and send metrics. But Kafka also comes with metric reporter. If you want to use a control center, then you can configure Kafka configurations and send all the metrics to the control center, and then you can use control center to the UI.
So you don't collect the metrics for the Prometheus.
Yeah. So JMX Prometheus exporter is already configured for each components. So we need a Prometheus scrapper to like pull those metrics. So that is out of the band, but we just provide the integration case. So it's almost done. So let's say CTL get Kafka, that's Kafka, that's OML. Then here, if you see the Prometheus port, so you just use your like Prometheus server configuration and then just hit this matrix. You just pull the matrix. We have a default like Grafana dashboard. so that you can deploy a Prometheus operator and just pull those metrics. But if you see here, it has all the information we required. Let's say you want to produce and consume, right? Let's hope like it already get resolved. Yeah, it's all got resolved. So DNS all set up, right? So we need to create a topic, Kafka topic. Okay, just give me a second. So Kafka topic, you can run like every component the Kafka pod comes with all the Kafka scripts. So I created a topic called what is that? Yeah, sorry, I can see here from here. Example 2. So as the topic got created with the partition 12, let's say I want to produce on this topic, example 2. So here, broker. So if you see here, the broker is actually pointing to the starting point. It's not pointing to each Kafka, like each broker mat data instance. And then producer has this Kafka configuration. This Kafka configuration actually is picked from this configuration. So you run this thing. So it got produced, right? And then we can come here. Let's consume that message. This is not a, sorry. Oh, my bad. Where I am. Yeah, so just give me a second because the topic is wrong there. This example 2. So she'll conjure. Oops. Yeah, because the Kafka property is not there. I asked such a here. So should, yeah. So you can just within like 10 minutes, we just created a whole Kafka cluster, create a topic, produce and consume, and yeah, that's it. And then one of the thing is if you want to do status, you can create you can get a status endpoint from the kubectl. Suppose the last demo is pretty all. If we want to do scale up, right? So parts that's and that's double, right? And then there's a Kafka. I want to scale up. So you just run a scale up command. Say, oh, I want to replicate to 4. It should just take care of creating pod with like one line. It takes care of upgrading, like running Kafka, new broker, does the right configuration, all this stuff. Yeah, and then there's a way to like override all the configurations if you. Any questions you guys have? Participants rebalance. No, so because as I said, scale up requires ADB, manual ADB right now. So we still have to go inside the manual run the ADB. Yeah.
But in our future, we plan to add that automated operation that you don't have to worry about.
So due to time, let's take just one question. And then after the whole session, we still have additional QA sessions for any of our speakers. Okay.
When are you going to open source it?
Okay, so when we release this, we have open source contract. But so what we'll have is operator and open source contracts coexist. The open source contracts will be pointing the deployments and stakeholders, but the operator as a custom resource controller will be the Confluent commercial feature. So the operator itself will not be open source, but the open source contracts will be if you want to use it.
Related question is,
Yes,
can the Confluent operator do the cluster auto healing and workload balancing?
Yeah, so because every services it creates, it watches those services. So every time that something goes bad with the services, it recreates those services. If that's your question.
A follow-up question is saying, if in the Kubernetes cluster, right, we have replication of 3, and we have 2 nodes died, so in that case, it will cause the
yeah. So
loss, right?
we run. So for Zookeeper, we have pod distribution budget. That is like a Kubernetes native, so that it doesn't allow you to like kill those pods. But if there are situations where broker dies, then we expect Kubernetes starts those pods back up. If something still goes down, then yeah, we like existing operator doesn't support that capability.
How about the load balancing part?
Load balancing part is because we piggyback the service type load balancer, so it is up to the implementer, like the cloud, like it's up to the provider to support the load balancing stuff. Yeah, thank you.
Thank you. Thanks, Rajesh.